Hello students, I welcome you all. This is the 8th lecture of this topic called Matrix. Today, let me start with remaining examples from the exercise 3.3, which are important for 3 marks. Students, let me begin with 7th question. The first question is, show that matrix A is equal to containing the elements 1, minus 1, 5, first row elements, second row elements are minus 1, 2, 1, and third row elements are 5, 1, 3. Is a symmetric matrix. You have to show that the given matrix is a symmetric matrix. Dear students, we have studied the definition of symmetric and skew symmetric matrices. The definition of a symmetric matrix is, if A is any square matrix, then A dash is equal to A, then such matrices are called symmetric matrix, and A dash is equal to minus A, such matrix or such a square matrix is called a skew symmetric matrix. A dash is equals to A is called as a symmetric matrix, and A dash is equal to minus A is called a skew symmetric matrix. Now in this example, we should have to prove that A dash is equal to A. Let me begin with the first question. The given matrix A is equal to the elements containing in the first row are 1, minus 1, 5, second row elements are minus 1, 2, 1, and third row elements are 5, 1, 3. Let me denote this equation as 1. To define the symmetricity, let me find A dash. Therefore, A dash is equal to, the first row is replaced by the first column 1, minus 1, 5. Second row is replaced by the second column minus 1, 2, 1. And third row is replaced by the third column 5, 1, 3. If you observe the equation about 1 and 2, this is equation number 2, equation number 1. By comparing equation 1 and 2, we find that A dash is equal to A. Therefore, the matrix A is called a symmetric matrix. Here is one more example, which is also of the same order. Question number 7, sub-question 2. Matrix is of third order. The first row elements are 0, 1, 1, second row elements are minus 1, 0, 1, and third row elements are 1, 1, 0. Now to prove that the given matrix is a skew symmetric matrix. Dear student, just now I told you the definition of symmetricity and skew symmetricity. A matrix is skew symmetric only if A dash is equal to minus A. Now in this case, we have to show that the given matrix is A dash is equal to minus A. If matrix satisfies this condition, then such matrices are called skew symmetric matrix. Let me start with the given matrix A is equal to containing the first row elements 0, 1, minus 1, second row elements are minus 1, 0, 1, and third row elements are 1, minus 1, 0. Now the first row is replaced by the first column 0, 1, minus 1. Second row is replaced by the second column minus 1, 0, 1, and third row is replaced by the third column. Therefore 1, minus 1 is replaced by 1, minus 1. Now A and A dash both are not equal. Therefore, let me take the negative sign outside from the above matrix. From this matrix, we can take a minus sign outside. Therefore, the first row is replaced by the first row. The first row, we have taken the negative sign outside. Therefore, 0 or minus 0 becomes 0. Then minus 1 becomes plus 1, and plus 1 will be a minus 1. Therefore, these are the first row elements after taking negative sign outside. Therefore, the first row elements are 0, 1, minus 1. Similarly, we have taken the negative sign from the second row. Minus 1 becomes plus 1 becomes minus 1, 0 will be a 0, and minus 1 will be a plus 1. Similarly, we take a negative sign from the third row. Therefore, minus 1 becomes plus 1 will be a minus 1, and 0 will be again a 0. Therefore, we have the matrix like A dash is equal to minus of, this is minus of, this is a given matrix A. Therefore, this matrix A satisfies the condition A dash is equal to minus A. Therefore, such matrix is called a skew symmetric matrix. Therefore, this problem satisfies the condition like A dash is equal to minus A. Therefore, the given matrix is called as a skew symmetric matrix. Moving to the next question, question number 8. For the matrix capital A, which is of second order, containing the elements 1, 5, 6, 7 in the first row and second row respectively, we have to verify that A plus A dash is symmetric and A minus A dash is a skew symmetric matrix. Now in this case, let me find the symmetricity. My dear students, in our 6th lecture, we have proved the theorem A plus A dash is always symmetric. This is proved. This theorem is proved in the 6th lecture. You can go through it. And A minus A dash is skew symmetric matrix. This matrix is called a skew symmetric matrix. Therefore, with this definition, we can show that A plus A dash is symmetric and A minus A dash is given example. Now let me begin with the first question. The given matrix A is equal to 1, 5, 6, 7. Therefore, its A dash is equal to containing the elements. The first row is replaced by the first column and second row is replaced by the second column. Therefore, this is our matrix A dash. Now let me find first A plus A dash. Let me denote A plus A dash as matrix B. Therefore, matrix B is equal to A plus A dash, that is equal to matrix A. Elements are like it is 1, 5, 6, 7 in the first and second row respectively, plus the second matrix which is called A dash containing the elements in the first row 1, 6, second row elements are 5, 7. Here we should find the A plus A dash. Therefore, matrix B is equal to, which is nothing but containing A plus A dash. A plus A dash is denoted by the matrix B, which is equals to, by adding the corresponding elements of both the matrices, 1 plus 1 that gives 2, 5 plus 6 it gives 11, 6 plus 5 again it gives 11, and 7 plus 7 that gives 14. Therefore, we denote this as equation number 1. This is our matrix B containing A plus A dash. Now, let me show that B is equal to B dash or B dash is equal to B. Because our B is nothing but A plus A dash. Let me take the transpose of B, which is nothing but a transpose of A plus A dash. Now, the transpose of B is nothing but a B dash containing once again the elements. First row elements become a first column and second row elements are second column. Therefore, that matrix is again 2, 11, 11, 2. From 1 and 2, we can see that B is equal to B dash or B dash is equal to B. Therefore, B is a symmetric matrix, meaning A plus A dash is a symmetric matrix. Therefore, A plus A dash is always a symmetric matrix. Dear students, same example, sub question number 2. Let me show that A minus A dash is a skew symmetric matrix. Now here the matrix A is given for us. We have to show that A minus A dash is a skew symmetric matrix. Let me begin with the given problem. Matrix A is equal to containing the elements 1, 5, 6, 7. Therefore the transpose of A is denoted by or given by 1, 6 in the first row, 5, 7 in the second row, because we know how to find the transpose of a given matrix. It is rows are replaced by columns or columns are replaced by rows. Now let me start with, let C is equal to the matrix A minus A dash. I am denoting A minus A dash as a C matrix. Both are same. Just for our understanding purpose, we are defining a new notation for A minus A dash as C. Therefore, that is equals to A minus A dash. We subtract the corresponding elements of A and its transpose. Therefore, we get the matrix C is equal to A minus A dash, and that is equal to 1 minus 1, it gives 0, 5 minus 6, it gives minus 1, 6 minus 5, that gives 1, and 7 minus 7, it gives 0. Therefore, we have the new matrix C, which is containing the elements 0, minus 1, 1 and 0. Therefore, here we have the new matrix called as C, and the C elements are, dear students, here is a small mistake. Instead of C, I wrote it B. You make it as a C. Therefore, matrix C is equal to, this is our matrix C. It is C is equal to A minus A dash, and their elements are 0, 1, minus 1, 0. To check the symmetricity and skew symmetricity, let me find the transpose of matrix C. This is C matrix. The transpose of C is nothing but C dash, which is equals to, or which is equal to, the first row elements are 0, minus 1, second row elements are 1, 0. Let me take a negative sign between this matrix, minus sign outside. Therefore, the elements left in this matrix are 0 plus 1 in the first row. Next row elements are minus 1, 0. Therefore, this matrix we denoted by equation number 2. From equation 1 and 2, we find that C dash is equal to minus of the given matrix C. Therefore, this matrix satisfies the definition C dash is equal to minus C. Therefore, C is called a skew symmetric matrix. But C is nothing but A minus A dash. Therefore, A minus A dash is always a skew symmetric matrix. Remember the students, A plus A dash is always a symmetric matrix and A minus A dash is always a skew symmetric matrix. Let me start with the 10th example from the exercise 3.3, which is very much important for the exam point of view. Express the following matrices. There are the two examples given for us as sum of symmetric and skew symmetric matrix. We know that A plus A dash is symmetric and A minus A dash is skew symmetric. The addition of these two matrices always gives a matrix A. We have to show this. In this problem, we are going to do the 3 steps. First, we are finding A plus A dash, which is a symmetric. And then let me find out A minus A dash, which is a skew symmetric. The addition of these two matrices always gives a matrix A. Means we have to find first A plus A dash, then A minus A dash. Then you have to show the addition of these two matrices again a matrix A. Let me start with the given problem. First example. Here, let me start with matrix A. The given matrix A is equal to 3, 5, 1, minus 1. Therefore, A dash is equal to, the first row is replaced by the first column and the second row is replaced by the second column. Therefore, both are transpose of each other. Now, let me find out the addition of these two matrices A plus A dash. We will add the matrix A plus A dash. Therefore, the sum of these two matrices is nothing but we take the addition of these two matrices A plus A dash. 3 plus 3 that gives 6. 5 plus 1 again it gives 6. 1 plus 5 it is equal to 6. Minus 1 plus of minus 1 that is our minus 2. Therefore we denote this as an equation number 1. Here A plus A dash is a symmetric matrix. Therefore 1 by 2 times A plus A dash is also a symmetric matrix, because scalar multiplication of a matrix is possible. Therefore 1 by 2 times A plus A dash is also symmetric. Now let me find what is A minus A dash. You have to find A minus A dash. Let me continue the same example. The second step of this problem is to find A minus A dash. Therefore matrix A minus A dash that gives A minus A dash is equal to 3 minus 0, 5 minus 1 it gives 4, 1 minus 5 that gives minus 4, and 1 minus 1 it gives 0. Therefore equation 2 is a skew symmetric matrix. If we check the transpose of A minus A dash, it will be a skew symmetric matrix. Therefore obviously 1 by 2 times A minus A dash is also a skew symmetric matrix. And let me denote it by equation number 2. From equation 1 and 2 we can show that this is our third step. We have to show that A is always equal to the addition of A plus A dash and A minus A dash. Our A plus A dash is a matrix containing the elements 6, 6 in the first row, 6, 2 in the second row. Addition means sum, and A dash is A minus A dash is containing the elements 0, 4, 4, 0. Therefore the sum of these two is equal to A is equal to 1 by 2 times 6 plus 0 that gives 6, 6 plus 4 it gives 10, and 6 plus 4 again it gives 10, and finally 2 plus 0 that gives minus 2. Therefore here we have dividing throughout by 2 to the given element. Therefore 2 into 6, 1 by 2 into 6, 3, 1 by 2 into 10, 5, 1 by 2 into 2, 1, and 1 by 2 into minus 2, minus 1. Therefore in this case we have the elements like A is equal to containing the elements 3, 5, 1, minus 1. Therefore the addition of symmetric and skew symmetric matrix is again a same matrix A. This is a very important question for the exam point of view, which will be given for 3 marks. Once again the question number 10, sub question 4, which is also of the same order. Here also we have to express the following matrix as the sum of symmetric and skew symmetric matrices. Let me start with matrix A is equal to 1, 5, minus 1, 2. Therefore the transpose of A is denoted by A dash, and the first row is replaced by the first column, second row is replaced by the second column. Now let me find out first A plus A dash. Now to show that sum of symmetric and skew symmetric matrix, you have to do the 3 steps. First is let me find out A plus A dash and show that it is a symmetric. As per the theorem, A plus A dash is always a symmetric matrix. Therefore matrix A plus matrix A dash, the sum of these two matrices is equal to the matrix containing the elements 2, 4, 4, 4 is a symmetric matrix. Therefore 1 by 2 times A plus A dash is also a symmetric matrix as per the theorem. Moving to the next step, let me find out A minus A dash. Now A minus A dash, it's a continuation of the same problem. A minus A dash is equal to the matrix containing the elements 1, 5, minus 1, 2 minus A dash containing the elements 1, minus 1, 5, 2 in the first and second row respectively. Therefore A minus A dash is equal to containing the elements. Here we subtract the corresponding elements of both the matrices. 1 minus 1, 0, 5 minus of minus 1 plus 6, minus 1 minus 5 that gives minus 6, and 2 minus 2 that gives 0. Therefore, here the matrix A dash is a skew symmetric matrix. We will denote it by equation number 2. Therefore, 1 by 2 times A minus A dash is also a skew symmetric matrix. Now the third step of this problem, you have to express A as 1 by 2 times symmetric plus skew symmetric. 1 by 2 times is a symmetric matrix plus skew symmetric matrix. Therefore, we add the corresponding elements of the matrix, that is 1 by 2 times 2 plus 0, that gives 2, 4 plus 6, that gives 10, 4 minus 6, it gives minus 2, and 4 plus 0 again gives 4. Therefore, dividing throughout by 2 to the given matrix, 1 by 2 into 2, that gives 1, 1 by 2 into 10, it gives 5, 1 by 2 into minus 2, that gives minus 1, and 1 by 2 into 4, it gives 2. Therefore, after writing the addition of symmetric and skew symmetric matrix, we got a same matrix A, which is 1, 5, minus 1 and 2. Therefore, the theorem is verified. Dear students, here we have the one more question which is also of the same type, but in this problem the order of the matrix is 3 cross 3. Therefore, A is a matrix containing the elements in the first row 6, minus 2, 2. Second row elements are minus 2, 3, minus 1. Third row elements are 2, minus 1, 3. Once again, we have to show that any matrix can be represented as the sum of symmetric and skew symmetric matrix. This matrix is our A dash, and A plus A dash is the first step to show that the sum of symmetric and skew symmetric matrix is always A. Therefore, A plus A dash is equal to, we add the corresponding elements of both the matrices, that gives 12, minus 2, it gives minus 4, 2 plus 2, that gives plus 4. Similarly, we can add the corresponding elements of the first, second row and third row respectively. We have the matrix containing the elements 12, minus 4, 4 in the first row, minus 4, 6 and minus 2 in the second row. Third row elements are 4, minus 2 and 6. Therefore, 1 by 2 times A plus A dash is also a symmetric matrix. Now, the second step of the problem is to find the matrix A minus A dash, the difference between A and A dash. That gives A minus A dash is equal to a matrix containing the elements in the first row 0, 0, 0, second row elements are also 0, 0, 0, third row elements are also 0, 0, 0. This is by algebraic operations on matrices. We got a 0 matrix and we denote this matrix as an equation number 2, and a 0 matrix is always a skew symmetric matrix. Now the last part of the problem, we have to show that from equation number 1 and 2, any matrix A can be expressed as the sum of symmetric and skew symmetric matrix. Therefore, 1 by 2 times, this is a symmetric matrix plus skew symmetric matrix. Matrices, we have A is equals to 1 by 2 times. The first row elements in the first matrix are 12, minus 4, 4, minus 4, 6, minus 2, 4 and 2, 6 it is. Dividing throughout by 2 to all the elements of the symmetric and skew symmetric matrix, we have 6, minus 2, 2, then minus 2, 3 and minus 1. Then we have 2, 1 and 3. This is nothing but a matrix A. Therefore, any matrix can be expressed as the algebraic sum of symmetric and skew symmetric matrix, that is 1 by 2 times into the bracket A plus A dash plus A minus A dash. Therefore, A plus A dash is symmetric and A minus A dash is skew symmetric. The addition of these two matrices into 1 by 2 always gives a matrix A. With this, I conclude my today's lecture. For any queries, contact the given below number. Thank you. Stay home, stay safe.